Most people think the internet is simple. You type a name, you press enter, you arrive. It feels direct, immediate, almost effortless. But every time you use the internet, you ask a question. Not out loud, not consciously, but every website visit begins with the same request. Where is this? You type a name, your computer sends it into the network, and within milliseconds, you're connected. Not because the internet understands names, but because there's a hidden system whose only job is to translate them. This is the system that decides where the internet goes. The internet feels intuitive. You type a website, you arrive. It feels like the network knows where everything is, like information has an address that never changes, like every page has a permanent location. So, a belief forms. Websites live in fixed places. The internet remembers them. The system is simple. But computers don't understand names. They understand numbers. Every device on the internet has an address, not a name, a number. An IP address, a long string of digits that identifies a machine's exact location on the network. To humans, names are easier to remember. To machines, numbers are everything. Computers don't know what Google.com is. They only know something like 142.250.180.14. To a machine, that number is more real than any word. So every time you type a website name, your computer has to ask a question. What number is this name hiding? That question is sent into a system most people never see. That system is called DNS, the Domain Name System. It's not a database. It's not a single service. It's a global translation layer. A massive, decentralized system whose only purpose is to turn human-friendly names into machine-readable locations. Every time you visit a website, DNS is consulted first, before content loads, before encryption begins, before anything appears on screen. DNS always happens first. If DNS fails, the internet doesn't load incorrectly. It doesn't load at all. When you type a website, your computer doesn't know the answer. So it asks a resolver. The resolver is usually provided by your internet provider, your company network, or a public service. The resolver doesn't know either, so it asks a root server. The root server still doesn't know the answer, but it knows who might, so it points the resolver to a top-level server. The top-level server points to an authoritative server, and the authoritative server finally returns the number. Only then does your computer know where to go. Every page load triggers a chain of invisible questions, a silent conversation beneath everything you see. DNS feels centralized, like a phone book for the internet, but it isn't. No single authority controls it. No global owner exists. No master copy is complete. The system works through trust. Each layer assumes the next one is honest. Each answer is accepted without proof. If one layer is compromised, every layer above it believes the lie. The internet doesn't verify truth. It assumes it. When DNS fails, nothing looks broken. The cables still work, the servers still exist, the internet is still technically on. But names stop resolving, websites vanish, APIs fail. Cloud services disappear, not because they're gone, but because the system can no longer find them. The internet becomes a city with no street signs. Everything is still there, but nothing is reachable. This kind of failure is especially dangerous because it's silent. There's no explosion, no shutdown, no clear moment of collapse. Users just see errors. Engineers see timeouts. Systems retry endlessly, but no one sees the real problem. The map is gone. DNS isn't just fragile, it's powerful. Whoever controls DNS can block websites, redirect traffic, silently reroute users. Governments use DNS to censor. Corporations use DNS to track. Attackers use DNS to steal without detection. The system doesn't move data, it decides where data is allowed to go, which means it decides what exists online and what might as well not. Modern infrastructure is built on top of DNS. Cloud computing depends on it. AI systems depend on it. Smart devices depend on it. Banks, hospitals, power grids, emergency services. Every modern service begins with a name. And every name must be resolved before anything else happens. DNS sits beneath everything, quiet, invisible, assumed. As systems scale, DNS becomes the single point of assumption beneath the digital world. Not the fastest system, not the strongest system, but the most trusted one. And trust is the only thing holding it together. The internet feels vast, global, distributed, too big to fail, but it's held together by translation. A system built on trust, without verification, without central protection. DNS survives not because it's secure, but because everyone assumes it will keep working. Until it doesn't. The most powerful systems don't store information. They define access. They decide what can be reached, what is ignored, what exists, and what effectively disappears. This was another unseen system. If you want to understand the hidden infrastructure that quietly shapes everyday life, and what happens when it starts to fail, subscribe to Unseen Systems. Because the most important systems are rarely the ones we're taught to see.